Hello, everyone. Thank you for joining us for the Cellular Gateways for IoT webinar, where we'll discuss keeping costs low and deployment numbers high. Before we get started, I'd like to share a bit about who we are. IoT is an award-winning IoT software company that enables organizations to quickly and efficiently manage their IoT devices. We make this possible through interoperability and lightweight M2M. Before we get started, a few housekeeping items. The webinar is being recorded, and the slides and the recording will be sent to you after the webinar. Also, you may have noticed that all participants are currently muted, but we strongly encourage your participation and would appreciate having your questions through the chat for the end of the webinar, where we'll do a Q&A session. For today's agenda, we'll discuss 3 different topics. The first is when to use LTE-M or NB-IoT for a gateway. The second is using lightweight M2M to lower the cost of your gateway fleets. And the third is solutions for a sustainable energy ecosystem. Today's speakers include Ulf Seijmer, who is the Chief Innovation Officer at Induo and the CTA and co-owner at Accurate. We also have Thomas from PySense, who is the founder and CTO. And we have Olivier Carmona, who is the VP of Sales and Marketing at IoT. Ulf?
Thank you very much. And let me see if I can just get the control from you as well. Thank you very much for the introduction. So we're going to talk about the mobile networks. And the first time I came in contact with the term 5G was roughly 10 years ago. So a magazine reached out to me and asked me if I could write them an article about 5G. So this was in 2012. And at that time, we were most of the time using just the 3G networks. We were super lucky when we found 4G coverage. And whatever 5G was at that point, well, hardly no one knew. But my vision for 5G was that the 5G networks would be intelligent networks that would connect the world without boundaries. So remember, this was a vision from over 10 years ago. And then time passed, 3GPP designed the 5G standard, and they designed it basically on 3 extreme use cases. So in one corner of this triangle, we have one extreme use case called enhanced mobile broadband, basically fast internet connection. In the other corner, we have ultra reliable low latency communication. So communication with low latency for remote controlled cars, remote surgery, and such things we want to do with 5G. And then the last piece of the puzzle, massive machine type communication, massive IoT. Large-scale IoT deployments with millions of devices per square kilometer. So massive IoT using the mobile networks, well, it could be done in 2 ways, basically. Either you have a sensor that communicates directly to the base station, or you have a sensor using another wireless communication standard, communicating with a gateway that in turn is communicating with a base station. So if we have just a sensor transmitting to the base station, if a sensor fails, then it's just one sensor. But if we have the gateway in between and we have several sensors, the gateway becomes a very crucial point of our setup. So if this device fails, we affect many sensors. So the gateways, they could be equipped with with other wireless interfaces to communicate with Bluetooth Low Energy, WirePass, Matter, LoRaWAN, for example. But in this setup, the gateway is super important. So some people say that 5G is still a vision and 4G is what we're using. But when it comes to LPWAN, it doesn't really matter because 4G and 5G, they share the same wireless standards for LPWAN, narrowband IoT and LTE-M. So these two, they are in two different releases. So LTE-M has two different versions and NB-IoT has two different versions. They all originate from 3GPP releases. So the version 2 is a little bit faster than the first version. But if we compare these two, we notice that NB-IoT has a significantly lower speed and a lot of more latency. So this makes narrowband IoT not the ideal standard to use for gateways. I'm an advocate for LTE-M1 because I think it's best for the gateways and many other LPWAN use cases as well. So how do you use a mobile networks to its full extent? I'm an advocate for limiting data that is being sent from the actual gateway. And why do you want to keep the data volume down? Well, first of all, if we reduce the traffic volume, we don't have to pay the operators. If we limit the traffic volume already at the gateway, we're not feeding the operator. We can sort of filter data where it's generated. Ultimately, we will reduce power consumption, which is a good thing these days. And the third thing is that if we limit data already at the edges, we can reduce the need of cloud storage. So I'll share an example of how we try to do this in the gateways. So we create a filter, and at the moment I'm standing at my office, and my office room is normally between 22 to 24 degrees warm. So if I create a filter that filters out all this unnecessary data, because I know that it's normally 22 to 24 degrees inside, and then we can just take the values outside of this data span and consider these. So if we read a sensor data and we see that it's 23 degrees, we will just put it in the waste bin. We'll wait for the next reading and we will repeat that. We will save some of these data points for later use to map out trends, temperature trends, but we don't need to have regular readings. But if we have a temperature value which is below 22, for example, say 18 degrees, we would like to have this data saved, and then we can save it in batches and send it together with the other temperature trends. We can also make sure that if something is way out of limit, say that it's 16 degrees inside, we can take action and send this data immediately to our cloud service. And speaking about sending data and cloud, when you use the mobile networks, you have some security layers already in place. You have the SIM card, for example, in the device. You have a good encryption. I think it's a good practice to add also other means of encrypting your data transfer, like TLS encryption. If for some reason your solution don't allow it, you can always use something called private APN. And the private APN is basically a way to transmit data through the operator's network without making the data accessible on the internet. So it's sort of a private network within the operator's network. And then you can fetch the data using a secure connection to the operator. But this doesn't add any extra overlay to your data packages. So looking at the device, I've been working with the mobile networks for more than 2 decades. And one of the things that we always recommend is to automatically reboot the device on a regular basis. We do this because then we sort of reboot the whole device. We don't just reinitiate the connection, we reboot the device. So that will clear out the caches, and it will address a lot of issues that can build up over time. I mean, these devices and these solutions are meant to be in the field for 10 plus years. So we want to make sure that we do this on a regular basis. You want to have a device that has some kind of watchdog, at least a firmware watchdog that keeps track of the firmware. And if it isn't executing, it will reboot your device. There are also other devices with hardware watchdogs alongside the firmware watchdogs. And that is basically a second processor that keeps track of your first processor. And its only task is to see if it's executing code. And if it's not, it will reboot your device. A third thing when it comes to device security is to have a physical security layer where you can make sure that your data isn't tampered with. So if someone gets your gateway, they cannot extract the security keys, for example, or encryption keys. When it comes to device management, it's very important to measure what's going on in the device. So if we monitor different metrics in the device, like signal strength, for example, we can make sure that the device is up and running all the time. And when we measure signal quality, we don't just measure the signal strength, we measure also some signal quality metrics. And to be honest, if the signal looks good, we don't send it across. We just discard that data and send it whenever it's needed. So we send them as trends, not in every data package. It's also important to be able to receive updates to the device. In some cases, we change the update frequency. We turn on or off LED functionality, for example, to be able to find problems more easily in the field. Firmware updates, super important. This will be mandatory within EU in the near future. There is new legislation coming called Cyber Resilience Act, and that will require all hardware manufacturers and even distributors to make sure that devices can be updated in the field. So looking for different ways of monitoring your device. We can have either a platform built on an open standard. The flexibility is high because we can add different brands into this platform. Or we can buy something from the manufacturer directly. The flexibility is very low. We cannot add other devices into our platform. If you use an open standard and you decide to use the platform you build, it's a high threshold, but data integrity is good. When you buy something from another vendor, you don't have control over the whole system. Even though the implementation is high, you don't know every aspect of the solution. So to summarize, if you're looking at an edge device like a gateway, you want to make sure that you take a couple of considerations before you purchase the device. Do you want to process data, or do you want to transmit data? Do you want to store it locally, or do you want to send everything across? Do you need to make any additional changes to the device? Would you like to add your own code into it? Then what kind of language does it have? And again, does it have storage for what you're trying to achieve? And again, firmware over the air very, very, very important. So should you buy a device or should you build a device? Being a distributor of hardware for almost 3 decades, we decided that we actually wanted to test and build the device ourselves. So that's the Accurate device being born. And if you're thinking about this yourself, it's very rewarding. It's very fun to do it. But please remember that there are several aspects you need to address. I've met people that have purchased a hardware design using social media and paying a couple of $100. They haven't tested it in laboratory. They just deploy it in the field and hope for the best. If you're going to design hardware, make sure that you have good and capable resources in your network that can help you with the hardware design if you can't do it yourself. Understand that hardware changes over time, and this landscape we have at the moment with component crisis, it changes even faster. Firmware is another issue. It will need to be updated, to the current specifications, current needs. And also testing in laboratory costs money. So building your own gateway, it will cost you a couple of €100,000. So make sure that you have the funds, but please go ahead. I'm very important. I think that we need more hardware solutions on the market. There are so many IoT platform companies, but there are fewer that actually make their own hardware. And I welcome that very much. That would be all for me. Thank you very much.
Thank you, Ulf. Thank you for your presentation. I think that it's obvious that when you want to start your IoT project, you don't want this project to be scrambled, changed. If you discover that you need to change your gateways or move to a commercial gateway in the middle of a road. So yeah, important to select carefully your options at the beginning of your project. At IoT Europe, we are very much here to help our customer build their vision and their deployment ahead, helping them to deploy massively devices that are extremely constrained. As Ulf mentioned just before, there are 2 options. Either you go with the option of using devices that will connect directly from the device to the cloud, end-to-end internet, and typically cellular IoT is a case for that. And there is a second option, which is the option that we will care about today, which is having a set of gateways that are at the edge of the internet. Sometimes they are the edge of the internet, so devices below are not internet sometimes. And sometimes all devices are internet, like in the case of Wyson. But you have a set of gateways that are either directly connecting to the internet or connecting through a net of gateways to internet using border router. In both cases, you will have a set of gateways. What we are observing since a few years now, we are getting into situation where companies are deploying a large set of gateways, and they cannot afford to use expensive gateways. They need to scale down their needs, and in terms of gateway, because they need not only 1 gateway, 10 gateways, 100 gateway, but they need 10,000 gateway, 50,000 gateways. And of course, they need to lower their cost on the gateway side. And that's where we are helping customers to particularly use cases like smart metering, street lighting, or any kind of large fleet assets. We believe that in the case of both deployment, where you have a large set of gateways, it's not anymore possible to launch a command shell on every of the 10,000 of devices you have, except that using a lot of your workforce for activities that are particularly dumb. And so you need a set of tools, of solutions for handling the basics of those gateways health. So you need a solution for you to be able to remotely monitor, diagnose those devices. You need a solutions to update the firmware. And as mentioned, Ulf, just before, the firmware update is getting into the Cyber Security Resilience Act. You must also be able to delegate the operations to your customers or to the customers of your customers, etc. So you also have the need to be able to perform operations on devices and not operations one device after one device. And last, you need to manage millions of events that are coming from those different gateways, and you need to act upon them, and you can't afford or you can't expect an operator beside each of those operations to be taking an action. So that's where we are helping, and we know that to do that you need a solution that will be able to run on your gateway, and those gateways that you want to spread in a large number, they can't be necessary. They can't be all running Linux. They can't be all running with a ton of memory. They must be low cost. They must be affordable because you need plenty of them. And for those cases, you need to have also a solution that can run on those constrained devices, not only on large devices. So that's in a nutshell what we are doing and what are the solutions. So the first thing you will be hearing is Go MQTT, sort of motto that you can hear somewhere. MQTT is a protocol. It's a message passing protocol. It's a protocol that will help you pass your message from your gateway to the cloud. It's certainly something that can help you being connected and send data to the cloud, but it's not a tool for you to manage your devices. If you expect MQTT to be able to bring you security, to bring you some sort of registration of your devices, or being able to do your firmware update, to do your device configuration, you will be able to do it, but you will have to build your own interface, your own tools, your own solution, your proper implementation, or you can use the proper implementation from a third party. Particularly, you have solutions from the hyper cloud vendors like AWS or Azure that have built their own solution, which is, of course, not compliant from one to the other, and that are relying on that protocol, which is not efficient and not made to communicate in both directions. It's essentially a protocol to communicate from a device to the cloud, not sending your firmware from the device, from the cloud to a device. So we believe that lightweight M2M is the answer, and that it has been always since it has been used for that and is used right now for all the automotive applications, for many applications for the telecommunication operators. And it's more and more used now by the utilities and the cities for them to be able to bring touchless installation, be able to provide access control to the devices, be able to diagnose the devices remotely, and offer all the necessary layers for security on your gateway. So we believe that lightweight M2M, and not we don't believe, but it is the case that a lightweight M2M offers device and data format interoperability. Whatever device you will be selecting, you will be able to conduct a firmware update operation from any lightweight M2M server. You will be able to drive the connectivity and to get the connectivity statistics and the connectivity status from the device from whatever server. And that's very extremely important. But in addition, there has been objects that have been created that helps you in your particular business to be able to address a case for street lighting, for smart building, for smart metering, and over 1,000 objects have been gathered so that you can address those use cases. In addition, lightweight M2M is able to address all the device lifecycle. So from the device onboarding to the decommissioning, including the firmware update, there is an operation that you can already use and get, and so as to have a high level activity and high level operation that is already implemented in the protocol that will be able for you to be able to conduct this operation on your gateway. And that's extremely important. You will also have the capability to conduct the operations by doing the same operation on a set of device. You can select that set of device very easily using a set of criteria that you want on your fleet. You can select all the gateways that are all your firmware 1.0 gateway. You can select all your LTE-M gateways, or you can select all your 4G gateways, or all your accurate gateways. And that's all those things that you are able to do in a very simple operation, and that you can afterwards you can conduct an operation. Say you can trigger the firmware update on all of those devices, and you can even say, I want to trigger this firmware update to be taking place concurrently, 10 device per 10 device, or 5 device per 5 device, so that I don't overload my network. So that's the kind of thing that you will be able to do with device management, and that's an important step. We'll also be able to do a 24/7 monitoring of your devices. So if you have anything happening on your network, on your gateways, anything wrong, you can not only be able to get the information, but you can act upon this information. So you can trigger some action. You can trigger a notification. You try and trigger an action, and this, like, you can trigger a reboot. You can trigger also a command line on that device. All of those things are possible. You can also, using a device management, you can also configure your gateways all at the same time. So you can have multiple set of gateways. You can have accurate gateways. You can have LTE-M gateways, as I mentioned before. You can have 2G gateway or whatever. You can set and act upon them using a configuration profile, and be able to apply for each of these given profile the same operations. And you can onboard them, you can update them, or you can automate a lot of your work without caring about the fact that you have not 100 devices, but 10,000 devices, 10,000 gateways. It's also, device management is also crucial for you to maintain an ecosystem where you have multiple levels of management. You can have customers, you can have customers of customers, say, or you can have subsidies company. So you can have multiple levels, and everybody must access only to the devices they are allowed to. Here, it's extremely important that you give access only to the people that are allowed to access to the people. For instance, in this case, the team X from company A should access only to the team X devices. And in no case, the company B, which is client of A, should not be able to access to the company A devices, and they should be accessing only to their own devices. And last, the device management brings you also the capability to onboard your devices without caring much about what's going on at your construction, at your manufacturer level. You can provide your manufacturer with credentials, an address for a server that will be the Bootstrap platform without giving access to your manufacturer, to the production platform, nor to the certificate that will be used in production. The Bootstrap process is a very standard lightweight end-to-end process that allows you to do that in one single operation. And this is extremely important to keep your OEM out of the loop. So that's about what device management brings. So I understand that you should have understood, I hope, that you have understood that device management is extremely important. What we bring on top with Alaska, our platform, and Iowa, our client, is the capability for you to really scale up your gateway system, and as well be able to rely on an implementation of lightweight end-to-end, which is extremely efficient, which is able to be accessed using Java, Python, but which is also very, very, very efficient in terms of bandwidth usage. And as mentioned before by Ulf, the less data goes out of your gateway, the more it's efficient, the less you pay, the more you will be saving in terms of power consumption as well. So if we talk and look at how Alaska differs from the rest of the device management servers that are implementing all the features I mentioned just before, it's a solution which is natively built for microservices. So it's a solution that can scale without limit. It's a solution that we can deploy in a place worldwide using the intrinsically native of its microservice-based application solution. It's also a solution which is extremely maintainable. We have not only supported a lot of objects, there is a lot of objects included and provided in Alaska, but it's also a solution which we have connected to many third-party applications using a REST API, either as an API that you can access to get data from or to manage devices from, but you can also hook your own interfaces to third-party applications or third-party scales, hyperscalers like AWS or Azure. It's extremely simple to use. The documentation also helps you to go over how to manage your users and your tenants, how to manage your devices, how to manage your events, how to manage a firmware update. Alaska is also extremely adaptive. You can orchestrate your data flow. You can decide to get your data every hour, every day, and you can change that. You can change the observation to be every 10 minutes, maybe for a given day. You can change all of those things, whether they are, or whether this data is through lightweight end-to-end or through other data flow like MQTT or AMQP. You don't necessarily need to do everything over lightweight end-to-end. And you can use your preferred cloud services to transmit your data to. Last, Alaska plus Iowa are providing an important extensions to lightweight end-to-end because it allows you to not only monitor the gateway itself, but it allows to manage also the sub-objects that are below. So you can shadow any kind of device as a lightweight end-to-end device that will be visible as a lightweight end-to-end device inside your server using the gateway operations defined by the latest extensions of lightweight end-to-end. And that allows you to be able to access devices, whatever technology they use, whether it's a LoRa, a BACnet, a ZigBee device, a Matter device, whatever. You'll be able to connect and be able to monitor through the gateway. The gateway will be the platform that will be able to act upon the devices, but you will be able to see them and act upon them based on what your gateway will be able to address, actually. So we are a proud member of the Open Mobile Spec Works, who is designing lightweight end-to-end. We provide the most efficient implementation, and our solution is used across the industry to bring interoperability to bring also a solution that is extremely able to scale. We are also active in the field of smart grid, and I would like to give the torch to Pisons, our customer. It's up to you, Tomasz. Can you hear me? I can't hear you yet, Tomasz. I can see that you are acting, but I cannot hear you yet. Are you on? So maybe I can try to unmute you if you want. I can try to do that. I cannot. Probably Mackenzie can. Can you try to unmute Tomasz? Tomasz, can you hear me?
Oh, hello.
Yes, we can hear you.
Okay. So because unfortunately I wasn't able, to unmute my mic,
No
and
problem.
so I suppose that you can hear me at the moment. So thank you.
I can hear you. Yes, please.
Okay. So again, hello everyone. I'm Tomasz Leszczyński. I represent Pisons company. Thank you for our attendees which have joined us here at the moment. So, and I would like to show to more practical applications related exactly to the assumptions took and said by Ulf and Oliver related to the device management and the lightweight end-to-end and IoT massive gateways in general, especially for the energy ecosystem. So it means that to be able to build the applications based on the new kind of the IoT technologies and things related to the connecting of the data sources in the energy data points and energy devices like energy meters, for example. So let me check if I'm able to control the slides. Oh, okay, so it works. So massive IoT gateway, this is, the abstraction and the abstract word, which, let's say, touching the things related to the functionality and the technical side. We will cover that later, but as I said, so we will touch the subject related to the energy. Pisons is a company from the beginning focused on the energy applications and connecting the IoT world and the energy world. Yes? So it means the transmission of data from the different kind of the devices like the energy meters, water meters, and the heat meters, and for now, for example, the PV inverters. And the intention of Pisons is to build the new kind of the ecosystem to give the solution and tools to the prosumer to build the end-to-end application of the balancing of the production and energy usage in general. So if we talk about the gateways, because the portfolio of our company consists of different kind of the application and devices from the OEM modules through the standalone terminals to the software and the applications, but one of the most important at the moment, at least, there are gateways, which we'll show later, and the gateway is able to connect different kind of the energy data sources, as I said before, related to the energy. So we mean the things like energy meters, PV inverters, electric car chargers, energy storage, heat pumps, and few others, which are not listed here. But we have seen on the market the real demand to easily connect of all of these sources and the connection, because we can see on the market that there are plenty of the protocols really mass related to the understanding of the transportation layer, communication layer, and the idea was, to build a common application layer to connect all of these sources. Traditional smart grid versus what we are doing in Pisons in general is really related to the model of the communication which we are proposing to the customer, because we could compare here the traditional industrial IoT based on the heavy industrial IoT gateways equipping the heavy Linux operating systems, for example, in opposite to what we are doing, for example, based on the low-cost MCU and low-cost components to be able to build the real mass deployments, which can be counted, for example, in tens of the thousands or hundreds of the thousands pieces of devices deployed in out of the field. And definitely this is the way where which will speed up the IoT and energy IoT gateway and the energy ecosystem deployment of such of devices and the market. So definitely traditional approach is where the data are processed more close to the source of this data, so we can, for example, see at the energy meters, where the energy meters at this point are at least are like, so we can compare them to the computer, for example. So they are equipping the heavy processors sometimes, and the heavy communication and so on. The same in the industrial environment. But the Pisons approach is to process this data in the centralized manner, in the centralized location like the cloud. I will show later the real application and the full picture of the end-to-end system. And but it will give us some of advantages of this approach. And one of them is a lower cost for the gateway. As I said, our gateways are based on the microcontrollers, not instead of using the costly processors. Lower complexity to install and maintain the gateway. So it means that if the device is less complex, so the installation and deployment of those devices are easier. Higher reliability, definitely. If we talk about the devices, so we took a lot of discussion to our engineers and product managers and the customers. And from one hand, the building of the Linux-based operating system application sometimes is easier, so because we can take the path, take the curve of the development based on the higher level languages, like, for example, Java and Python, but there is a tons of the levels of this operating system which we don't have, let's say, access to. And the reliability of the drivers, for example, is not well known for us. Yes, so, and it means that building the solution on the microcontroller directly definitely gives us the higher visibility, exactly what happens inside the processor, inside the MCU. So it means that we are able to achieve the higher reliability in opposite to using the MCU. And of course, it's easier to scale, but this, let's say, buzzword is more related to all of the things I have touched before. So it means that if we have, let's say, the low-cost device and with less complexity and the higher reliability, definitely we're able to scale this to the hundreds of thousands of devices, for example. And we have selected the IoT Europe, exactly the lightweight M2M solution, both for the client side and on the server side, because it will give us the full interoperability between our devices and our cloud services, but not only so. It means that we are able then to sell devices to our customer where our equipment and the solution can be used. I mean, the hardware can be used by our customer, and they can develop the full application based on our hardware based on that. Yes, so which are without using our application layer then. So from the beginning, Pisons is strictly stick to the cellular technologies, and of course the 5G network is coming at the moment, but 4G and the 5G is mixed already, because some of the technologies, some of the stacks like LTE-M and narrowband IoT especially, touched by Ulf already, are the part of the 3GPP specification in a 4G world and the 5G network world as well. But I would like to add some additional technology here, like LTE category 1Bs, which is the form of the LTE category 1. This is the legacy LTE technology, which is available on all the networks over the world where the 4G is deployed, but with limited bandwidth and the easier and the less complexity of the deployment. So it means that we are able to use in the gateways not only CAT-M, which I fully agree to Ulf that this is much better technology than narrowband IoT, but definitely LTE category 1Bs can be considered that as well. And in our solution at the moment, this LTE category 1Bs is used widely because of one reason. CAT-M1 technology and LTE is very nice for the future. And if we can imagine, for example, the work of the cellular networks in coming few years, it will be the high runner for that. But at this point, there is some issues with the commercial deployment of that networks, and this is the answer in form of the LTE Cat1Bs for that. As we have said, and what exactly has been took in presentation by Oliver, the unified device management layer is a crucial point to achieve the real plug and play and the full interoperability between the devices and the cloud ecosystem and the software and the customers and so on. So we have used the lightweight M2M protocol smartly because we had in the past a lot of experience with the custom solutions. So we have built our own protocol to manage devices based on our own security layer and so on. But unfortunately, we were not able to achieve the full interoperability to our customer systems. Then, so we have faced a lot of issues related to the integration of that kind of the devices at the deployment stage, because the managing of the devices which are installed out of the field is the crucial thing, really. And we have, us till now, deployed like hundreds of thousands of devices, especially communication units in energy meters. And we know that the upgrading of the firmwares and the upgrading of the configuration is not theory only. Yes, so we are doing that in practice together with our customers, and the lightweight M2M is there already and definitely helps us to speed up that process. So, and here we can see the IoT massive gateway dedicated for the energy market, as we have, let's say, touched already. And I would like to show here the main parts which this gateway consists of. So from one side, on the left side, we have the wireless M-Bus and in general RF transceiver equipping 8 megahertz capability. So at the moment we have implemented the wireless M-Bus stack there directly. So it means this is a chip down design. but there is possibility, for example, to implement the Wi-SAN on other protocols. And thanks to this wireless M-Bus, we are able to connect to the energy meters, like electricity meters equipping the wireless M-Bus, and gathering the information, fetching the information from the HOMARA network. From the other side, we have the RS485 interface, electrical one interface, where we are able to establish the real transparent channel between the LTE and TCP/IP client to that kind of the devices, and implement the interpretation and the conversion of the protocol for the application layer like Modbus, DLMS, COSM, or IEC, which is a list of the very well-known protocols for the energy market at least. Of course, wireless M-Bus can be used to reading out of another devices like water meters, heat meters, and gas meters, or even the sensors. On the another side, we have the cloud solutions. We have built end-to-end and full plug-and-play Internet of Energy, so-called platform, dedicated to easily deploy the solutions like our IoT Massive Gateway. And as we can see, we have two main parts on the right side. So the one part is a device management channel, consists of the lightweight M2M, COP, and UDP protocol on the transport layer. And this device management, thanks to the IoT Europe Alaska server, is a part which is responsible for the plug-and-play subscription and provisioning of the devices in out of the field. So it means that all devices are equipped in the special keys and the credentials at the production stage, and then when are installed by our customers or the integrators, are communicated to the Bootstrap server. And this Bootstrap server, I mean the lightweight M2M Bootstrap server, is giving to our devices the credentials to connect to the main server. And the second main part on the cloud side, on the right side, is the application channel. As Oliver said, so we have seen the table with the comparison of the MQTT and lightweight M2M. And I fully agree that MQTT is, let's say, doesn't allow you to build the real device management, or at least to build this easily. But definitely MQTT can be used for the data transmission level, and we have used MQTT exactly for the wireless M-Bus push messages sending to the MQTT broker. And we have the raw TCP/IP, as I have said, transparent channel to the RS485, so we are able to put on the cloud the implementation of the legacy protocols like the Modbus or DLMS COSM, and manage those protocols in the client server way from the cloud side transparently to the device, thanks to the encapsulation and the encapsulation layer on our smart IoT gateway. And it allows us to manage very easily the plug and play of different kind of the protocols very easily, and tens of these protocols on the cloud side then. So summing up, our IoT Smart Gateway is, as far as I know, the smallest device on the market with this kind of the capabilities and this kind of the functionality. Is cost effective and definitely battle tested. So we have sold really huge numbers of that device to the customers, not only in Poland, but also over the world. As we can see on the right side, device which is equipped in the LTE communication in the LTE category 1 BEAST module for commercial bands, but not only. So we have the solution for the B31 equipping 450 megahertz, so can be used in the closed private networks in Poland, in Hungary, in Germany, for example. wireless M-bus 868 megahertz with the operation of T1 and C1 mode to gather and fetch information from the water meters. Half duplex RS485 electrical interface to connect any kind of devices equipped in this interface. It can be the energy meters, but not only, so we can imagine the PV inverters, the PLC controllers, and so on. USB interface for the local configuration. IoT lightweight M2M client, which allows us to manage device very easily, not only from our cloud, but all lightweight M2M compliant servers. MQTT client, as I said, which is used to transmit push information gathered from the wireless M-bus at the moment. TCP/IP to RS 485 transparent mode. And few others things which is listed here. So summing up my presentation, definitely would be the thing related to the lightweight M2M, because our intention and on the roadmap is to give to our devices lightweight M2M natively. So as Oliver said, it should be considered not only after everything is developed and produced, but lightweight M2M should be considered even before, so at the designing stage. And definitely all our next software release and next our devices will be equipped in lightweight M2M protocol natively, not only for the device management, but also we consider to use the lightweight M2M as an application layer, and to use the lightweight M2M new kind of the features released in the last specification 1.2 of the lightweight M2M standard, like lightweight M2M gateways. So it means the mapping of the legacy protocols and the data fetched by the local radio, for example, into the lightweight M2M object. So you will be able then to have the one interoperable system and the server like Alaska or others on the one side, and you will be able to device to managing of devices and transmission of the application data in the one point of the cloud then. So I think that I have touched everything. So that's all from my side. So if you have any questions, so send it to us. So thank you very much.
Hello. So thanks for this presentation, Thomas. So we have a couple of questions to address. I'd like to first start with you, Ulf. There is a question that is addressing the particular case of how do you deploy cellular like LP1 technology worldwide? What would be your recommendation? I think that the question can be, we are talking about gateways, but I think that I'm assuming that the question is how you build a device and ship it worldwide. And also, I think there is the question of a device like a tracker that goes from country to country. So that's the questions of the roaming, plus the question of the how do you do with just the initial setup when you send a device to another country.
The problem is that there is no one size fits all here. There are different frequency bands in different parts of the world, so you will have a problem finding a device that can work on both the, say, the North American market and the European market and the Asian market. There are such modules available, but generally it's tricky to find a device that supports everything. And then you have the two standards, NB-IoT and LTM. And for different parts of the world, LTM is more popular, and for other parts, NB-IoT. So basically, you will end up with most likely one hardware, but you have to make sure that it's individually configured for different markets. That's a short answer.
Thank you, Ulf. And the question is to talk about also the lightweight M2M portion of it. Of course, once you select the cellular technology, the cellular LP1 technology, lightweight M2M will sit on on top of it. There is no special activity that you need to do. It will work whatever link has been established from a cellular LP1 part. There is another question for you, Tomasz, about what LP1 chip is embedded inside the DIN 100. So you're not forced to say everything, but if you want to answer, Tomasz, please.
So yes, so can you hear me again?
I can hear you. I can hear you back. You're back.
Okay, so but can you repeat the question? So because
So the question is,
yeah.
what is the chipset that you use for the connectivity inside the DIN 100?
Okay, so thank you for the question. So we have two kinds of the chipsets there. So the if we talk about the LTE, for example, so we use at the moment two kinds of the modules supplied from Telit Wireless Solutions and from Simcom, equipping the Qualcomm chipset as a chipset in general. But if we talk about the ISM radio, I mean 868 megahertz transceiver, we use the Spirit 2. This is the S2LP from ST Microelectronics. So, and the heart of the device is the STM32 L4 microcontroller. So, I think that I have answered.
Thanks, Tomasz. Thanks a lot. So I think that I'd be also interested in having some other generic questions. So Ulf, can you tell us a bit more about your Accurate device and is the line card of Accurate? How many products do you have in Accurate? Is it a large range of devices that you are, or is it only one single gateway?
It's a single device that is deployed with a lot of functions that we can activate or deactivate using firmware, basically. So it's easier to build a device with a limited number of functions, and then we can add or get rid of functions using just firmware, basically.
And out of curiosity, there is a label on top of it, last mile IoT. Is it built in conjunction with this company?
No, not really. No, we designed everything in-house.
Okay.
So yeah.
Okay, so it's not related to the company last mile. Okay.
No. It's built and designed in Sweden and the UK, and type approved in UK, manufactured in Sweden. So it's quite a European thing.
Yes, good to precise, because it could be confusing.
Yep.
And Tomasz, do you want to add something about your product?
So I don't know.
No, okay. So
I think that I could, talk about our products,
for years,
for the hours or years. So definitely there is a plenty of subjects, it can be touched, related to the functionality, related to the openness for the development, for example. So definitely I'm available, for everyone which is interested in.
So I'd like to thank you, Ulf. Thank you, Thomas. Thank you, Mackenzie, for this session. I'd like also to thank the attendees, particularly thinking to Christos, Jason, Jimmy, and Biad for your question, and of course Wassim. Thanks for attending. More than happy to continue the conversation with those interested in. And before I leave, Jason has a question. What percentage roughly of devices connect directly through a gateway, and is this mostly tied to MNO pricing? So I can try to take that question, but maybe Ulf, you want to do you have an idea on that first?
No idea directly. I would say it depends really a little bit about the use case. And if the use case is that you want to use a gateway in a building and you have an indoor LoRaWAN network, for example, then you would use a gateway. If you have devices spread over a large area outdoor, well, then it's most likely using the mobile networks directly. So it's a little bit depending. From our point of view in Sweden, we pay roughly €1 per month for a SIM card, and for an IoT device, we pay like 50 cents to €1. So the price of the mobile networks isn't, I would say, that hard on the wallet or budget.
Yeah, I'd agree, Wolf, that the question is very much a question of use case. Large spread network won't be, large spread deployment won't be easy to do using a gateway, or you will have to put so many gateways, and sometimes with so less number of connected devices that it will be too much of a cost. But as soon as the density is high enough, it makes more sense. And then it may also make more sense in case where you are using non-IP technologies and you connect those through RF. So it's a trend that IP internet goes now end to end, but there is still a lot of I would say a lot of existing solutions that you need to address. So I don't think that the MNO pricing would care, though if you make the math, paying €1 per gateway is less expensive than paying €1, well, 50 cents to €1 per device. But it's not as easy as we've said. It's even sometimes you can't do that with a gateway, because that would cost one gateway for one device, and hence it's basically too much of an expensive solution, because you pay the gateway as well. I hope it answers the question, Jason. And with that, I'd like to close our discussion. Thanks for your time all, and have a great continuation of the day or evening. Bye-bye.